Okay, here we are continuing on, adding code into the methods inside each of our classes. This time around, we're going to be focusing on the room class. Let's get all of that functionality inside of room up and going.
All right, we need to load up the room class, which can be found over here under classes. And we're going to focus on the public methods first. So I need to go to the public methods region and expand that.
Let's see, before we even start putting stuff in, what all do we have? We've got describe what the room looks like, show the title of the room, get an item from within the room, let's see, add an exit to the room list, remove an exit from the room list, can we exit based off a direction we send it, and then we've got a couple private methods. We've got, let's see, get item list, get exit list, and get coordinates. All right, cool. So let's see if we can get all of the meat into each of these different methods.
All right, let's begin with describe. We need to have describe, of course, show its description, and show the items and exits in the room as well. Now, of course, to output information, we're going to be using our text buffer. So I have text buffer. We'll add some information to the text buffer, and that first piece of information is going to be the room's description. So I will use the keyword this to refer to this current room, and I'll access the description variable. Now, of course, we also want to add item list and exit list. So we'll begin with the text buffer. We'll add to it. Now, for getting the item list, that's a private method that we'll be coding in here in a minute. We'll still refer to it using the this keyword. We'll say this dot get item list. And there's no arguments to get item list, so we'll finish that off. Terminator, and that will take care of adding the get item list. And we have one final thing, which is our text buffer. We'll add to it this dot get exit list.
Very cool. Now, Logan has used the keyword this several times, so even though I said I was going to try to avoid doing some whiteboard action, let's do a little bit more. In the case of rooms, we've got a class, so this is going to represent our class and all the code inside our class. And with room, we want to be able to have multiple instances of room running in the game. So multiple copies, multiple objects, all of type room. So from this class, let's go ahead and draw it like this. Here's a room. Here's a room. And again, we're going to be going over object-oriented programming in much more detail later. But this is just to give you conceptually what's going on. So there's three rooms, right? All derived from the class room. Now, when we are inside each of these, and when we're coding it, right, and we need to refer to that particular instance of something, that is when we use this. So we know that if we're inside this particular object and we say show the description, if we say this, because remember, the code is actually written all the way back here. So at the point of us writing the class code out, we don't know about this object. That object doesn't exist yet. It gets created later. So by using the keyword this, then what happens is when this object is actually running and that method is called upon, it knows that it's talking about its own instance. Hopefully that'll help.
Right, because we have a bunch of different rooms to deal with, so we need to deal with, well, which one, in this case, this current room, meaning the one that we're currently looking at.
Precisely. All right, let's go and hop back over there. Just want to draw that out real quick.
All right, so that should cover what we're doing with the this keyword within the describe method. Now we can move on to the show title method.
Oh, this one's going to be so challenging, ladies and gentlemen.
Again, we're going to be outputting text, so we'll use the text buffer's add method. And we'll add this dot title. And that's it.
Okay. Very cool.
And keeping up with our habit of building, let me do a quick build and make sure that we're doing good so far.
So far, so good. All right, so the next one's going to be, you going to do get item now?
Yep, now we're on to get item. And this is where things get a little bit more interesting. I'll take out the return null that I had temporarily placed within get item, and let's begin a loop. We'll use a for each loop, and we'll say for each item in items. As a matter of fact, if we want to keep with what we've been doing with the this keyword, we could say this dot items. So the items list relevant to this room object. We'll block in the for loop. And now, for each item, we want to do a check and see if the item that we're looking at is equal or has a name equal to the name that we're passing. So let's do that check. We'll say if the item, this item that we're looking at inside of the list, dot title dot to lower, so we'll compare it as lowercase, is equal to the item name that we're passing, dot to lower, again comparing them in a lowercase fashion so that they're compared in a case-insensitive manner. And if that is the case, if the item we're looking at has a title equal to the passed-in item name that we've passed to getItem, then we want to return that item. So we will return item. And if we reach the very end of this loop without finding anything, then we want to return a null object, indicating that we did not find any item that matched this item name.
Okay.
And
now,
before we go on, I'm going to do a build, just make sure we don't have any syntax errors, and that takes care of getItem as far as code goes.
Now, let's spend just a second and talk about for each, since we're going to see it a few times throughout Hyperion and many other applications in the future. So for each allows us to walk through each object inside a list. A list, you say? Well, let's start out by first looking at items right here, right? Actually, let me switch over here and grab the mouse. So we've got items. Well, just putting my mouse over it, look at the little pop-up there. It's a list of room.items. So we know it's a list. And we talked back over in Photoshop in the whiteboard in an earlier lesson that basically that list, it's kind of like a shelf, right? And on the shelf, we can put objects. And in this particular case, what kind of objects are we putting over there? We're putting items in the list. So now let's hop back over to our code real quick just so that we can see what's happening here. So we're saying for each item in this.items. Man, I'll tell you what, that's a lot of items right now. So it might seem a bit confusing. So let me point out the case, because the case is very, very specific here. So we've got the for each, and then we're saying item. And if you remember, it's color changed. And then we say item in, and Logan threw in this dot items. Now, we just saw that this right here is this list of items right there, right? Now what we're doing is basically we are setting up kind of like a temporary container that we can put an item in. And it is of type item. All right, now that's going to seem really confusing to those that are completely new, but you have seen us at this point do things like, let's make a variable that is of type string, and it's going to be called, give me something quick, Logan.
Like cat.
Cat. And inside a cat, we can, if we wanted to, we can come down here and say cat is equal to meow. I don't know, I'm just making stuff up, right? So we're putting meow inside of cat because this is a variable. Well, here, think of it like a variable. It's an object so that we can put an item in it. So look at it like this. Here is item. This is a list of items. I'll just say of item, okay? So now what for each is going to do is it's intelligent. It knows to start at the very first one, pull that item out, put it over here in item, and then we can do some work with it. And if we jump back down over here to our code, that is exactly what's going on. So we've got item out here. Now we can come down here and say if item, so now it's an object, so we have access to its title. So again, let me jump back over to the whiteboard. So let's pretend that this item was a cat. So we've got our cat over here, and now we can say the cat's dot, and then we have access to all of its properties because it's the object. So we can say the cat's dot color. Is it red? Is it whatever? You know, you see what I'm getting at?
Exactly.
So we do one, and then in this particular case, if I jump back over here, Logan is doing a check. He's taking the title of the room, or excuse me, the title of the item, setting it to a lowercase. So if it was capital C, then small at, it all becomes lower cat. And then we're comparing the item name that got passed into this method. Here's where it got passed in, the parameter, item name. We're comparing the title of what we just pulled out to the text that we just sent in, lowercase. So all that basically comes down to is we're saying, all right, this item.color, let's say it's blue. So then basically, let's say that right there returns a blue. We're saying is blue equal to blue. Let's say if that's what we sent into the parameter to compare. So that's how we've extracted all the way down to the point of what we're comparing. And then, okay, it does the comparison, does what it needs to. Now, again, back to the for each. It is going to loop through every item. So now it takes the next item and drops it over here. So let's say it was a dog. So then this would become a dog. If a dog was what was stored in here, if that was that particular item. And then again, same thing. And then finally, here it knows this is the last one. It puts this guy over here. So it is a way for us to walk through each object in the list and do stuff with it. It's a loop. And again, we're going to cover loops in great detail later on. But that just gives you a really quick idea of what's going on.
Exactly. Just like you were saying, the for each is going to get an item out of the items list and put it in this item variable so that we can work on it later.
Exactly.
And I believe I did a build on that, and we were okay there.
And looking good, absolutely.
So now we can move on to add exit. Inside of add exit, we need to take this direction, see if it already exists within this room, and if it does not exist in the room, add it to the list of exits that belong to this room. So we need to begin with a check and see if whether or not we already have this direction as an exit. So we need to ask and say if this dot exits, this is talking to the exits list that is part of this room, and we're going to ask it the index of, let me just do open parens, so yeah, let me retype that. Index of, and now we can pass it any or some direction. In this case, a string, because we're operating on string when we're talking about exits.
And you can see the parameter coming into the add exit method is string direction.
Right. So we're going to ask for the index of direction within the exits list. And if that, let's see. So if this index of, again, this is much like when we did the extract command and extract arguments. If the index is equal to -1, that means we do not have this direction inside the exits list. If it's anything other than -1, then we already have it. So we can say if the index is equal to -1, then this room does not currently have this direction as an exit. If that's the case, then we can add that direction to our exits list. So again, this dot exits dot add, and then the passed string, so direction.
The bottom line is we want to make sure we don't add north twice or 3 times.
Exactly, and pollute our list with a bunch of unnecessary information.
You got it.
All right, and of course a quick build, make sure everything is happy. Now we can move on to remove exit, which is going to begin in the exact same manner, where we check to see if this direction is a direction within the room. So same as before, this dot exits dot index of the incoming direction is equal to negative. Okay, then this is where it changes a little bit. What are we checking for? We're making sure that we do have this direction. So if index is anything other than -1 or is not equal to -1, then we can remove the exit from this room. So this dot exits dot remove, and we will remove the direction we were talking about. So direction. All right. That looks good.
Go ahead and do a quick build.
Oh, yeah. We'll build, and everything is looking good. All right. Now we can move on to the canExit method. So for canExit, we're going to be asking the room whether or not we can exit in a specific direction. So I'll take out our placeholder return, and we can begin looking for valid exits for this room. This is going to be another loop because we need to look through all of the exits within the exit list and see if any of those exits are equal to the one that we're asking for.
Now this time, instead of a for loop, or for each loop, we're doing just a regular for loop, and we'll be covering those and looping a little bit later on.
And actually, in this case, we're probably just thinking about it. A for each would probably be the most efficient.
Okay.
In this case, so
Logan's changing the code up a little bit on the fly. That's cool.
Because again, we can address this in the same manner as before. Go ahead and get one exit out of all of the exits, store that in a temporary exit variable.
Absolutely.
So we can do a for each, and these are going to be of type string because exits are stored as strings within a room. So we're going to have a string.
I'm going to call it valid exit.
Valid exit in exits.
So check it out. Using this for each, it's a little different than last time, where last time we were pulling objects, well, it's still an object, but we were pulling objects of type item out. Now we're pulling objects of type string out and storing them in valid exit.
And you'll also notice I've changed the name of this variable a little bit, whereas before we kind of had item, which almost seems to match items. In this case, just to prove the point that the variable name could be whatever you want, I've chosen the word valid exit for the variable name. So with this valid exit, and it is a valid exit because it exists within the exits list, that's what makes it a valid exit, we can do a check and say if the direction that we are passing to canExit is equal to the valid exit that we have pulled out of the exits list, then we can exit from this room, and so we will return true.
Remember, just before he codes anything else, the method that we are in returns a Boolean value, true or false. And so he is exiting out of this method and sending true back to whoever called it.
All right. So that means as we're looking through exits, if we do happen upon a valid exit, we'll return true. Now, after this loop runs, if we get past this point, that means that no valid exits were found within the exit list, so we need to return false, telling whoever called this method that there was no exit in the specified direction.
Okay.
All right.
Let's go ahead and do a quick build.
Oh, yeah. Let's build, and exits does not exist in the current context. And I typed exists. And just to make this a little bit clearer, I should probably go ahead and throw in the this.exits.
Okay.
Just like we did with the items. And now when we build, everything is happy.
And that is why we're going to try to build after each method.
Exactly. All right, that's all of the public methods for Room. Now we can move on to the private methods. First of which is getItemList. So getItemList, this is actually where things start to become a little bit more interesting, because the purpose of this method is not to return anything, as you can see. Well, excuse me, I was jumping ahead of myself. It does return, but it's not. What was the word? It's not they're not usable outside of this method.
Okay.
Or outside of this class.
Because it's private.
Precisely.
So somebody within this class is going to ask for this information.
Right. And what I was getting at is its job is to assemble just a block of text.
Mm-hmm.
So it's going to be assembling a bunch of strings. As a matter of fact, it needs to do things like show the text items in room, then maybe underline that text, and then go through each item and add that to the list of text that it's going to be returning, and then finally give that back to whoever called it.
And if anybody's confused, just close your eyes and think about when we were demonstrating the Hyperion game running. Remember, each time we got a description of the room, right up underneath it, we got items in room, and then an underline underneath that, and then a list of the items in that room, and then underneath that, we got a list of exits or directions that we could go, an underline, and again, the different directions that we could go. And these are the two methods responsible for making that happen.
And yeah, as you were saying that, I was just laying in some of our variables. The item string, which will contain the different items that exist in the room. The message, which will begin with items in room. Now we need the underline text. And this is going to be a little bit more interesting. I'm going to say that string underline, let's see. Actually, I need to begin it and initialize it before I start using it. So I'm going to say that we'll have a string variable called underline. I'll then turn around and use underline and access its pad left method and tell it to pad left for the number of characters that are within message. I'll explain this in just a second. So message dot length, and the character that I want to use for padding is the dash character. And the reason I'm doing the underline like this is so that we can have a variable automatically fill itself with the necessary number of the dash character in order to equal the message's length, this message being this variable here. So that way we'll have a list of underscores that looks something like this underneath it, where it will go and take out all the characters, count how many there are, and put a kind of underline under it.
Right.
And let's see, we've got underlined. Yeah, it looks like that's right.
Okay.
All right. Now that we have some of the initial values for these for this text block set up, now we need to go through all of the items and add those items to this list of text. We need to begin by making sure that we have some item to add. So we'll begin by saying if, or checking our items. As a matter of fact, I want to check this by using this dot item. So this room's items.
And the nice thing about a list is it gives us a count automatically. So we can check it with count.
We'll check the count. If the count is greater than 0, then we do in fact have some items, at least one. And then I'll block this, or set up this if block. While I'm at it, I'll finish off the if block, adding an else, so we have what to do if we don't have any items in the list. We'll just say, or echo out the word none, just so that way we don't ever have some blank area underneath it. We either say no items, or we have a list of items.
Okay.
So if there were no items, we need to set item string, this variable that we initialized up here. So item string, set it to equal, I don't know, let's add a new line, so \n, and then the word none. Just to indicate that there's in fact no items.
Okay.
Okay, now inside of if there were items, now we need to loop through all of the items, much like we did when we were checking to see if we could get an item out of the room, and just display each of those out. So we'll begin at for each. We'll set, let's see, we'll say we're grabbing objects of type item, storing them into a variable called item. So for each item in
the
this dot items.
Okay.
Lock this in. Now we need to, for every single item, add on to the items string variable. So we'll say items string plus equals, again, much like we did in the
so items buffer. Is equal to items, what's currently in there, plus a new line.
So new line, I'll do a little open bracket character, and then I'll add on to that with the item that we're looking at and throw in its title.
And then we'll add into that a closing square bracket. Now that closing square bracket, just nobody get confused. The opening and the closing, those aren't special code symbols. That's just us putting square brackets around the item names that we're going to write out to the console.
Right, that's just what we want to display for the item
list. So look, we're, setting into place.
Okay, so with these loops in place and the possibility to show something in the case of no items, now we need to take this string we've assembled and show it, or get it ready to be shown. We will return, we'll start by returning a new line, so that as we're returning this, we'll actually go after whatever had been described.
Right.
So add an extra blank line. And to that we'll append the message, again, this message up here. To that, we'll append another new line, and we'll add the underline that we had set up earlier. And finally, we'll add the item string that we've been putting together thus far.
Very cool. And let's go ahead and make sure that builds.
So we'll do a build. Item string does not exist in the current context. Item, I used items plural, which wasn't a variable we had defined in that context. So we'll build again, and now everything is working.
Very nice.
Alright, now we can move on to getExitList, which is much like getItemList, only applying to exits. So, if you don't mind, I'm actually going to start by copying... No, we could copy the entire thing, because it's going to look the same. It's going to have the same listing format. So just to save on time, I'm going to grab everything within getItemList. So there we have... starting with the first variables, ending with the return. I'll copy that. I'll jump into getExitList, and I'll paste it over that return. So we're getting rid of the placeholder return and pasting in the getItemList.
Okay.
Which would probably work. It would just give a duplicate of the item list right now.
Exactly. So we need to change a few things around.
So we'll begin by changing the variables so they make more sense in this case by calling it something like ExitList or exit string. Say I used item, exit. Okay, that makes sense.
Okay.
And message can stay the same, underline can stay the same, though the value within message needs to be changed to possible directions. So
again, the text that's being written out to the console.
And we might as well capitalize that just to make it look better. So that works for that. Underline can stay the same because we're still addressing the same message. Now we need to jump down to the for each and make this make more sense. To begin with, we're looking at strings when we're looking at exits. So we need to change this to string. And for
now you jumped over the if block real quick where you're checking items.
Oh, okay. We need to go back a step. We're still going through the items list at this point.
Right.
Instead, we need to go through the exits list. So we need to first begin and look at exits, see how many exits we have, and as long as we do have exits, then we run the loop. Otherwise, we go down to the none section. All right. So with exits, now we can come down to the for each. So for each, we'll call this exit direction in this dot exits. So we'll go through each exit, we'll take our exit string, I'm just going to copy this name. We're saying that we're adding on to our exit string, and we're adding a new line.
So doing it exactly the same way.
So yeah, same formatting. We'll have square braces or square brackets around it, and this time we're doing the exit direction. This exit direction, grabbing its, we don't have to grab a title because an exit direction itself is a string, so we can just directly add exit direction into the whole string.
Precisely.
Now let's see, we use none the same, so we just need to change exit string down here. And then within message, one last time on the very end. So this was just copying this exit string variable name for the none case and for actually showing it and returning it.
Right. And of course we want to make sure it builds.
So we build, and everything is happy.
Okay.
Alright, now that brings us to the last method in Room, the GetCoordinates. And again, this is more of just a debugging method so that we could easily print out the coordinate of the room we're currently in.
Right.
This will be a lot more useful when we get to level testing.
Now this one's going to definitely seem cryptic. Like I said, breathe and take it easy. Just see if you can follow along. Don't understand it. If you do, awesome. If you don't, it's not a problem.
Okay, so to begin with, again, taking out the placeholder return, now we need to begin another loop, only this time we're no longer using for each. We're going to use the basic for loop, and this is a little bit more complicated to set up. We need to set up an index variable and initialize it to a specific type. I'm going to start this one as an integer called y, initialize it to 0. Then I'm going to have the loop continue as long as y is less than our level. We're going to access level. We're going to access its rooms property, and the rooms, we're going to ask for the get length, and we're going to ask for get length in dimension 1. Confused yet?
Yeah, I'm not even going to attempt to break this down for them yet because I'll just leave them very confused. You guys can think back to when we went over the Photoshop lesson where we talked about what the room looked like, where we had X representing columns and Y representing rows. So here's a loop where we're starting at 0. That's our first row because it's Y. And now what we're about to do is set up another loop inside this loop so that while we're on that very first row, we can step through each column box.
And this is going to look pretty much the same, just replacing y with x and the dimension with 0 instead of 1. So again, we'll begin a for loop. We'll have an integer x initialized to 0. We'll continue looping as long as less than our room's length, this time in dimension 0. And then we'll increment x for each iteration of the loop. Alright, and what this is doing is allowing us to walk through each room within our room grid in a two-dimensional fashion. So, with this we should be able to look up individual rooms by using their coordinates. So the first thing we want to do is, since the purpose of this method is to get the coordinates of this room, we need to see if this, meaning this room, is equal to the rooms that, or the room that we would grab by using our x and y coordinate variable. So x, comma, y. And if so, we can return a string that holds the, or displays the x and y coordinates. So I'm going to begin the brackets just like we did before, for just for visual sake. So we want to open a bracket, display our x coordinate. I'm going to use x's toString method so that we can directly show an integer variable and put it into a string. And I'm going to add onto that a comma character, and then we'll add our y value, so I'll take y to string, and then I'll add on a closing square bracket.
Confused yet? I know you are.
Alright, so that's what we do if this room is within the grid point that we found, and technically this should always find the room. As long as the room properly exists within the room's grid, this should always be what we end up finding.
Right.
If something went wrong somewhere, or maybe the level designer had something unaligned or otherwise had an error, we could technically have a room that's outside of the room grid, so we want to give a default return message. And if we found this room to not exist within the grid, then we can say something like, this room is not within the level. I'm going to call this rooms, just because that's how we've been referring to it. Grid. So if we find a room, then return some coordinates. If we don't find this room within the coordinate grid, then just say just that we were unable to find the room within the grid.
Right. Now, if I can take just a second.
Sure.
Well,
actually, let me build and make
sure
sure we've got everything working.
Yep.
And we're good.
All right, so if I was to come over here real quick into Photoshop, and let's see, can I go through here and back up, and how much can I just pull out? All right, forget that. Too much stuff. Guys, hang in there for 1 second. I'm going to go ahead, come in here, and drop in a new layer real fast, and we'll switch these around, and let's go ahead and just paint it, and add one more, switch these back, switch myself. I just need to write this out as an action, and life will be good. Now, just a quick reminder, even though I know that that was definitely cryptic looking, I just wanted to give you just a quick idea of the looping part of what's going on. So, we set something up, a very simple grid, kind of a revisit back to one of our earlier lessons. And we know that we have X is going across. This represents our columns. And we've got Y that's going down. And as we said earlier, this is going to represent our rows. And if you remember what the loop does, that basically it's a loop nested inside a loop. Okay? And here's what I mean. Here's an outer loop, and here's an inner loop, and both of them start at 0. So Y starts at 0, X starts at 0. We could have called these whatever we want, but it makes sense to call them X and Y. We could have called them row and column if that would have made things easier for you. So we start out with Y equal to 0. Okay, so we're looking at this very first row, and then we fall through down to the next guy. So we set Y starting out at 0. Now we fall down to the next loop, and we're going to finish this loop first before we go to the next iteration in Y, in the loop above. So we start out 0 here, and then we're going to do some stuff inside, and then we get to the end of it, and we're going to come back up here, and we're going to check, is X less than how many rooms we have across, basically. So what that's going to look like is this. It's going to allow us to say, all right, so we're going to start out with X is 0. So now we're looking right here, 0, 0, and then we can do Logan's check. And then X increments, or it asks, can we go bigger? I mean, is X, do we have more room to go? Yeah, well, we've got to go, we can go all the way down to here. So it says, all right, well, let's make X 1 now. So with Y still at 0, we're now looking at this room. Again, we can do some checks, do whatever we need to. Then once we've done that in the loop, we come back up again and we say, all right, well, do we have any more? Are we still less than the number of rooms we have going across an X? Yes, we have another one. So let's go over again. So X is now equal to 2. And then we can, of course, now we're over here in this room based off what Y currently is and X currently is. We get information from it. We do what I need to. And at that point, we're done. We then in the loop go back and say, can we go again? Do we have any more rooms? Nope, that's the maximum number of rooms going across. So at that point, jumping back over to the code real quick, so at that point, no, we can't go across anymore. So it's like, all right, well, then we're going to fall through our loop. Now we hit the end of the first loop, which means we come back up and we ask ourselves, Well, how about y? Do we have any more rows that we can go down? And the answer, of course, is yes. So check this out. So now we're going to come down, and y becomes what? 1. So now y is pointing right here. All right, well, when that happens, what happens next? Now we fall down and we do the internal code inside this outer loop. Well, it starts pointing x at 0 all over again. So x now becomes 0. And with x at 0, okay, x at 0 and y at 1, we're right here. And we can pull stuff out, we do our checks, do whatever we need. Once we're done with that, again, we come back up in x. So again, we did all the stuff that we needed to for Logan. Hit the end of that internal loop, the nested inside for loop, come back up and we say, hey, can x go more? Do we have more rooms in x that we can keep going, more columns? And of course the answer is yes. So since the answer is yes, x becomes 1. So now we're right here. We do the stuff inside the loop. Then we check to see, can we go over even more? Is there another column available? Yes, there is. So now x becomes 2. Now we're over here. We do what we need to. And then in the loop, we come back up and we say, is there another column we can go to? No, there's not. So again, we're in this situation. Is there another column we can go to? No, there's not. So we fall all the way down to here. Well, after falling all the way down to here, it means we got to fall down to here. If we fall down to here, that means we're going to hop right back up here and ask, all right, and why? Do we have another row we can go to? So at this point, hopefully you're starting to see columns, rows. That's what GetLength is. I'm hoping that this starts to give them kind of a mental picture. So do we have yet another row? Well, yep, what do you know? We've got y equals 2. All right, well, with y equals 2, guess what? Now we fall down into the loop again, and what happens? X gets initialized back to 0, and we're going to start walking through X and doing the same stuff that you saw in the other two subsets, if you will, once again. So we start out with X being equal to 0, which puts us now at X0, Y2. That puts us right here. Then we do our stuff in the room. Now can we go further? Of course we can. So now we're right here because Y hasn't changed. It's still pointing right here to this row, row 2, okay? And now we do stuff we need to in this particular room. Then we check again, do we have yet another column that we can go to? Yes, we do. All right, let's step over there. And so now we're right here. Now right here, again, we can do our stuff inside that loop. Now it's going to check, do we have another column we can go to? And the answer is no, we do not. So then we fall again. Check it out. So we're right down here, or excuse me, we're right here. Do we have yet another column we can go to? No. So we fall down to here, which means we then fall down to here, which means we then come back up in our loop again, and we ask, do we have another row that we can go into? And look at this. Do we have another row that we can go into? No, we do not. So look at this. Now we've done the loop inside a loop, and this is every single room that we've just visited, okay? Now, does it mean that we have to hit every single one of those? No. If we end up with that position, we return. That means we completely get out of the method, okay? All right, Logan, make sure I didn't mess anything up as I'm dragging stuff around. Yeah.
Right, I think it just moved one parenthesis, so we can move that back in.
Very good.
Rebuild, and now
Excellent.
we're good.
Okay, so I know that still may be confusing, guys, but for some of you, I'm hoping that gives a very fuzzy picture of the loop inside a loop. All right, is that everything we needed for the room class?
I think it does. The one thing I do want to do is put a region around the private method, since if we're looking at something in this area, the only thing that gives us a hint that we've gone into the private section is the end region and the private methods.
Gotcha.
So it would probably be a good idea to start our own region for private methods. And then go to the very end and end that region. Because now, if we wanted to, if we were done looking at private methods for now, we can collapse the whole thing.
Very cool. All right. Anything else?
I'll do a build. I'll run just to show that, yes, the program is still working, and that will wrap it up.
Okay, well, thanks a lot, guys, and that is going to conclude putting all of the code within the methods inside of our rooms class. Thanks a lot.